All right, so we're on page 131 of your textbook here. Pearson, Saskatchewan Science 9 is where we're looking. And we're talking about describing matter in this lesson, okay? Describing matter. So get your notes package out here. In the space below, I am going to do a little exercise with you, and I'm going to ask you, how would you describe yourself? So I'm going to get some different responses from around the room. Give me one word that you would use to describe yourself. Anything. Let's take a random sample. Unique. Okay. Unique. Can you clarify unique? What do you mean? Unique in what way? Like, what do you mean unique? What do you mean? A little bit more specific. Not the same as what? Okay. So you're not the same as other people. Okay, what I'm trying to do is I'm trying to get down to descriptive words that would be, so in what way would you not be the same as other people? Fun. Okay, you're fun. Okay, I can handle that. Fun. That's a little bit more specific than just unique. Now, go ahead, think about that some more. What makes you different from someone that's nearby you? One random thing. Are you the same height as the person next to you? No. Okay. Do you like the same things? Maybe you like something that that person doesn't like. Okay. So let's say height makes you different. Okay. Now unique is just it encompasses a whole bunch of things. So I'm just trying to drill down to specifics. Okay. So height. What else? Expressive. Okay. So when you say expressive, what do you mean? Do you mean like your facial expressions? Do you mean like your ability to be brave and just and talk and share your opinion? What do you mean?
A lot of times when you
Okay, so expressive, you're talking about in your facial expressions sort of thing. Okay, so let's write that down for sure. Expressive. Okay, yes? Energetic. Okay, so energetic to do things. Is that what you're saying? Energetic to do things? Okay, so let's put that down as well. Nice. Some more, just real quick random ones. Yeah. Athletic. Okay. So when you talk about athletic, that would be your ability to do sports or things like that, right? Okay. So athletic. Let's put athletic down there. Okay. Okay. Couple more. Yes. Caring. Okay. Caring. I like that. Caring, like that. So you care about other people or other things, other animals or whatever. You care. Okay, good. We have one more? Okay. Loving, similar to caring. I like that. Yeah, I like that. Anything else? Creative. Okay, creative. You get this is like really big, like sort of mysterious, sort of like all-encompassing words you're giving me. That's very good. That's very good. So creative. I'll put creative here as well. Okay. So I didn't hear many people talk about height. Like, are you 5'6" or your weight or the color of your hair, like stuff like that. So hair color, I'm going to put down here. That's a good one. Some people would say, yeah. Okay. We do have height, eye color as well. Okay. Now, I've got to finish this word. Creative. So the reason why I'm doing this little exercise here with you, and the reason why I'm writing some of these words down, and the reason why I've separated some of these words, I've actually separated these words purposefully. Okay. So how would you describe yourself? Some of the ways that you could describe yourself would be in ways that are sort of physically measurable, okay? So like height, okay? Facial expression, right? How much your muscles move in your face, right? Some people are not very expressive, right? Like, that was a funny joke. And you can like hardly tell their face moves. Oh, that's hilarious. Try not to laugh when someone does that. Actually, you should try that sometime. If someone tells you a joke, try to laugh without actually smiling. Right? Like someone tells you a joke, just go like, that's hilarious. That's funny. That's super funny. Okay, try that sometime because it's like so weird. Okay. That's expressive. Okay, athletic. Okay, listen to this. Your ability to jump, to move, to catch, to throw, to spike, to shoot. Okay, these are like physical kind of things. Your hair color, it's a description of what the color is of their hair. Now, you can hardly tell what color my hair is because I hardly have any hair anymore. But that's something. Now, on the other side, right? Fun. I like to have fun. I like to interact with other people and things and watch comedies and tell jokes and laugh and joke with my buddies. Okay, you're energetic. Okay, so inside of you, you have energy to do things, right? You're caring. Okay, you care for other people. You are you see someone in need, you help them, and you're creative, right? You like to imagine. Now, can you see why I put those words on separate sides of the screen right there? Yeah. Okay. So what we're doing now, when we describe matter, there's different ways that we can describe matter. Sometimes it's with measurable things like height, muscle movement, ability to jump or to run, the color of something, right? The mass of something. Those would be sort of specific types of observations, and then the description of how they interact or the description of them would be another thing. So let's keep going here on the next page of your notes. We're talking about describing matter, and of course we can describe people in these ways, but we can also describe things in these ways. So describing matter is important. The ability to describe things accurately is important in the process of scientific inquiry. So let's see, where are your blanks here for this page? Accurately, okay? The ability to describe things accurately is important in the process of scientific inquiry. Now, inquiry, if you are inquisitive, or if you have a question, or you're curious, that's what inquiry means. Like, I wonder what the solution is to that, or I wonder why that is. So if you are curious, the ability to describe things is important. So obviously, look at this little chart I've given you. One of the ways we can describe things would be, is it a solid or a liquid or a gas? Well, solids would be things like a skateboard or a pencil, an apple, or a computer. Liquids, water in the pool, juice, soup, rain that falls, and gases, obviously, air that you breathe, the gas in a balloon, okay, the steam coming out of an iron, the fog in the morning on a cool fall morning, let's say. And so these are different ways that you could describe matter. This is not the only way you could describe matter, but these are some of the ways, maybe the more obvious ways that we could describe matter. Yeah?
A hot air balloon would not be, it would be a solid, wouldn't it?
Okay, a hot air balloon. Okay, well, the reason why this is because the gas inside the balloon is what we're talking about, not the actual basket and the balloon. Yeah, that would be solid. You're right. Good question. Okay. So the reason why I wrote those words when you were describing yourselves in two different sides of the paper there is because there are two really main types of observations that we can make, or descriptions. One is called qualitative observations. Qualitative. Now, these types of observations are observations that describe or note characteristics or qualities, such as the color, taste, odor. Okay. Now, I realized that I'd put the color of your hair on the one side, so we can talk about that. They weren't maybe broken down perfectly, but generally descriptions are qualitative. If you describe something like the taste, or how fun you are, or how caring you are, stuff like that would be quality. Quantitative, these are observations. Quantity, these are observations that deal with measurements, such as length, density, volume, mass, temperature, okay? So how high, what's your height, what's your weight, okay? How long is your hair? That would be a good one. The color probably would be a qualitative. The length of your hair would be quantitative, okay? So let's go back. I'm actually going to go back to that. Where was that page? Oh, was that just above? No, this last page. So I'm going to go down here. I'm going to adjust this now. I'm going to adjust this a little bit. I'm going to adjust this. I'm going to change this hair color. Actually, I'm going to take hair color, and I'm going to put it more with these ones over here. I think that's probably a better way to do that, because color is not a number. So if we're talking about quantitative and qualitative, then that would be a better way to do that. We could talk about hair length right here. This would be a better one to put on this side. So these now are quantitative observations, and these would be qualitative, a description of the quality. Yes?
Would it be also
Yeah. Yeah, yes. Yeah, you could talk about that too. The goal here is to sort of kind of get you thinking about quantity or measurements and quality or descriptions. Okay? So you're on the right path there. Other blanks here that I need to highlight. Let's see. Characteristics, you should fill in your blank there. And measurements, thank you. Okay, so qualitative qualities, quantitative measurements, or quantity. All right, so what are some of these characteristics or some of these descriptive words? Now, you're going to learn some words here that you probably never heard of before, and some of these words are really strange, okay? And I'm not even sure if you could even say those words properly, but this is malleable. Malleable. It's pretty much how it sounds. This is ductile, okay? So malleable or ductile. These are descriptors of how solids behave, or what their qualities are like. So for example, malleable means the material is able to be hammered or pressed permanently out of shape. So if you have like a metal wire or something like that, you could bend it or hammer it down, right? And it would not spring back into its original shape. All right? Malleable. Something you could hammer or press permanently. And it will do that without breaking or cracking. So if you had a piece of plastic and you tried to hammer a piece of plastic to flatten it, it would just crack and break all over the floor. But maybe a piece of metal, you could hammer that and flatten it right out, and it wouldn't crack and it wouldn't break into 1,000 pieces.
Is it 'cause it's...
You get that? So the description of malleable, okay, so if something is able to be hammered without it cracking or breaking, then it is very malleable. That would be a description. It would be highly malleable, or it would be very malleable. If you hammer a piece of plastic and it breaks, it would not be very malleable at all. Yeah, you would bend it, it would break, or you would hammer it and it would crush into 1,000 pieces. So it's kind of like, are you fun or are you not fun, right? This would be, are you malleable or not malleable, or is the piece of metal malleable or malleable?
Are there like certain ingredients for malleable, like stuff to make up?
Well, okay, so what makes something malleable? Okay, so some metals would be malleable. It would have to do with the structure of the atoms and stuff. We're not going to talk about that just right, but it's kind of how the atoms on the atomic level would be structured, how they would be layered. Okay? Yeah.
People hit some.
Yeah, sure. Some types of plastics you would be able to hammer or to, press, and they wouldn't crack or break. And those plastics would be more malleable than others. So again, I'm not saying that all plastics are not malleable. I'm saying that more metals are malleable and more plastics are not malleable. So we're just describing the descriptor right now. So ductile. What does ductile mean? Ductile describes the material's ability to be stretched into a wire. Okay? Now you're not going to come across these words very often, but it's important to know what they mean. So ductile. So for example, the lights that we have here in this room come from electricity that travels through wires in the wall, right? We turn the light switch on, electricity flows into these lights, and we get light. And so the wires that connect the switch and the light and the power source, this metal is actually like twisted and pulled so that it can be drawn into a wire. Now, some things are able to do that, and some substances are not able to do that very well. So if something is very ductile, it means it has a high ability to be drawn into a wire, like copper and that kind of thing. If you have another metal that when you put it into a machine and you roll it or stretch it and twist it and it just breaks, it's not very ductile. Okay? So again, we're just kind of going over some of these strange scientific words that are some descriptors. Okay? So you're going to run into these words. So malleable and ductile. Let's talk about transparent, translucent, and opaque. So these are also some descriptor words that are important to know the difference between. So transparent, a material that allows light to pass through so that objects behind can be distinctly seen. So if you can see through something very clearly, like a piece of glass, right, the window, if you can see through that very clearly and the objects on the other side can be seen very distinctly, then that substance would be called very transparent. All right? So these glasses here, these lenses are very transparent. I can see through them quite clearly. Transparent. And there's a little picture of I don't know if that's a piece of glass or if that's a bubble or what. That almost looks like a big bubble, but it's maybe just a round piece of glass on a counter. I don't think that one's a light bulb. The one on the far right, yeah. We'll get to that one. Okay, translucent. So transparent, translucent, a material that allows, now I'm going to write this word here. I made a blank, some. So the blank that you have there is right here. It should be allows some light to pass through, but not detailed images. So if you have some kind of like tissue paper or some kind of, colored plastic paper, something like that, or some plastic, like a garbage bag, like a shopping bag, maybe those plastic shopping bags at the grocery store or whatever, and you can kind of see what's inside, but not really. That would be translucent. So somewhere between perfectly see-through and not see-through would be translucent. Okay? So, but not detailed would be in the other blank. And finally, opaque, a material that blocks the passage of light. Now, I actually don't like this example because this is a light bulb, so light actually comes through this. I don't like that example. This was the example that I had in my notes here, but there would be lots of other things like this mug or a rock or a person. Light cannot travel through. Something that's opaque, right? Light does not travel through. You can't see anything through there. So in a sense that this colored light bulb, I cannot see what's behind it. That would be it's fairly opaque. So it would be fairly opaque.
So like with that flame.
That blocks the passage of light. Sorry, did you have a question?
Yeah.
What's your question?
With the flag.
Okay, so the flag, would it be translucent? Well, the flag on the wall over there, okay, can you see sort of some blurry images of what's behind that flag? Yeah, so that would be translucent. Very good. Yeah, so if you can partially see through it, translucent would be a good descriptor. Okay? Any other questions? All right, you guys are doing good. You're doing good. What about density? Have you ever heard of the word density before? Density? Okay. If something is very heavy and small, you would call it very dense. Okay. So the examples here would be high density foam and low density foam. So I'll zoom in there a little bit. You can see that this foam on the left is pretty densely packed. It doesn't have a lot of air pockets in it, right? The foam on the left, on the right, okay, this foam has lots of little air pockets in it, right? You can kind of like, it would be more like a sponge. A sponge would have low density. There was not a lot of mass in the space that the object takes up. High density would be there's a lot of mass in the space that the object takes up. So let's see. I have, this thing right here. So I have this little ball right here. This little ball is from an old style mouse. You know the mouse, computer mouse, where you turn it over and there's that little roly ball, okay? So this came from a mouse, and I'm gonna pass this around, okay? Just hold it and feel it and pass it around. Don't throw it, okay? Don't hurt anyone with it, but just take a quick piece of it here, and I will get this back from you in a bit. So if something's very small but very heavy, it's very dense. If something is very large and it doesn't weigh a lot, doesn't have a lot of mass, that means it's less dense. Okay? So a styrofoam cup would have low density versus like a ceramic mug like this, right? If you had a styrofoam cup or a plastic cup the same size, it would be quite light. And whoa, there's stuff in here. I gotta be careful, it's spilling all over the place. Okay, just water. But okay, so density. So it's the amount of matter in a given space. Now I'm also going to write here. You should write here the amount of matter. This is equal to mass. Okay, amount of matter, we measure that in mass. And space is, what's another word for the given space? Volume, very good. Volume, okay? So density is literally mass divided by volume. So I'll write that down as well. The amount of matter in a given space, density is specifically calculated by taking mass and dividing it by the volume. And then the density will have the units of whatever the mass was, let's say it's grams, and whatever the volume is, let's say it's milliliters. So density, if you took grams and you divided it by milliliters, then the density units would be grams per milliliter, and they could be other units as well. Okay? But it's mass divided by volume. Any questions? Yep.
How would you do that for like the mug or a cup?
Okay, so how would you do that? Okay, so how would you find the density of a mug or cup? Something that's like irregularly shaped and stuff like that? Okay, good question. You could take this mug and put it on a scale and weigh the mass, okay? So let's say it's 1 kilogram. Let's say 1 kilogram. And the space would be a little trickier to calculate. Now, if it was a block, if it was just a block, you could measure the length and the width and the height, multiply them together, and get the volume. But this is very irregularly shaped. It's hollow on the inside. So one of the things you could do, oh, I did spill a lot. I spilled all over my, okay. One of the things you could do is, well, does anyone have an idea of how we might find the exact volume of this? Yeah.
You could be like one of those water scales things where it's like you put it in the water and then it like shows how much is the difference of the water.
Okay, so one of those water things, and then you put it in, and then it shows the difference in the water. I like it. I know exactly what you're talking about. Yes, that is perfectly correct. If you had some kind of large container, and you knew exactly what the volume of water or liquid or whatever would be in that container to begin with, and then you took this mug and you placed it all the way in and dropped it down to the bottom of that big container, you could measure the rise in volume of that container, and that difference would be the exact volume that the mug would be. So that's called volume displacement. So you could measure by displacing. Good question. If something is heavy, it doesn't mean that it's highly dense. For example, if I had the world's largest styrofoam cup, and it was as big as a city block, and it was 200 meters high, I wouldn't be able to lift that styrofoam cup. It'd be super, super heavy. But because there's so much volume space that it takes up, if I took one little piece of that styrofoam cup, a smaller volume, and took the mass, I would find that it's still just styrofoam. So the density would be low, even though the mass of that object would be super huge, right? So yeah, so just because something's heavy, it does depend on the amount of volume that it occupies as well. Okay? So if I took a whole truckload of feathers, a whole truckload, if I could try to pick up a whole truckload of feathers, like in this huge bag that's the size of this room, I might not be able to lift it. So heavy, right? But a feather is very light, and the space it would take up would be very small. The mass would be very small, therefore its density would be small. So if I had enough of anything, it would be too heavy for me to lift, right? So the density is mass divided by volume. If you have a large mass, but you also have a large volume, then the density might be pretty small still. If you have a large mass in a very small volume, then density would be high. Okay? Okay, another way to describe material would be combustible. Again, these may be words that you're familiar with. Maybe this is the first time you've heard of it. If something is combustible or very combustible, this describes the material's ability to catch fire. So you may not have enough space to write catch fire there, I'm not sure, but The ability to catch fire. That's what combustible means. And burn easily. And it depends on how combustible it is. So for example, gasoline. This is a picture of a gas pump, right? So gasoline is very combustible. That's why you put gasoline in your car, because that little bit of gasoline lights on fire really quickly and it's very explosive, and that's what makes your car run. Okay? Unless you have an electric car, it's a little bit different, but fire burns very easily and it's very reactive, and it burns very easily and catches fire very easily. Something like a piece of concrete or cement would not be very combustible, right? You could put a match to a piece of cement and you could put it there for a long time and it wouldn't catch fire very easily. So cement would not be very combustible. Water is not very combustible. That is not easy to light water on fire, right? Uh-huh. Can you? Under certain circumstances, I suppose you could. But it would be very difficult. Water needs fuel and oxygen. Fire needs fuel and oxygen. So if you have something to burn and you have oxygen available to feed that fire, then it could burn. So, good question. Under what circumstances could you burn water? That's a great question. Somebody should look that up sometime. Okay, question over here.
Concrete
near. Won't it what? Okay, well, there's lots of different things that could happen if you put something in fire for long enough. Yeah, it could. Fire heats things up, and it heats gases up. It makes them expand. So one of the things that could happen is something could explode, maybe because of the gas that's being heated up inside and just kind of breaks free and explodes. You could have obviously some reaction. There could be some soot or burning of the, but its ability to catch fire and to stay on fire would sort of be its combustibility. So yeah, there's a lot of things. If you threw something in a fire for long enough, there's some different things that could happen for sure. It depends on the material and the circumstances. Yeah. All right, so let's move on to chemical properties versus physical properties. Okay, so we've got different types of observations, like qualitative and quantitative. We also have different types of properties, like chemical properties and physical properties. So let's talk about those. Chemical properties. All right, characteristics which are exhibited in as one substance is chemically transformed into another. So chemical properties, this is the definition of them. They are characteristics which are exhibited or that you see or can observe as one substance is chemically transformed into another. So when we have a chemical reaction, chemical properties will change. And one of the big things here is that if you have a new substance that's being formed, you know that there's a chemical reaction. And we're talking about chemical properties that are involved in that. So the next point says chemical properties are properties that do change the chemical makeup. Now, the blank you could put just change or do change in your blank. Properties that do change the chemical makeup of matter. So you remember we talked about the chocolate chip cookie the other day, right? When you separate the chocolate chips from the dough, you aren't actually making a new substance, you're just kind of separating those things. So think about if we took that chocolate chip from yesterday and we cut it in half, okay? Am I making a brand new substance by cutting a chocolate chip in half? Like, do I all of a sudden have Jell-O? No. It's still chocolate chip, it's just been cut in half. A chemical property would be something like we talked yesterday about, making something in the kitchen. Like if you, flour and water and salt and eggs and whatever else you put to make whatever. I'm not a cook. But anyways, if you put all that stuff together and you mix it up and you put it in the oven and you let it cook for 10 or 20 minutes, you have something new that comes out of the oven, right? You don't have all those individual things anymore. You have something new. That would be like a chemical change. The chemical properties would be the things that are that you would be able to notice there. So what are some examples of chemical properties changing or chemical changes? Would be something like reactivity, so how it reacts with certain substances, okay? Flammability and rusting. Now there's no blanks for you to fill in here, but here's some pictures. Flammability would be how how well something burns. So the combustibility would be more like catching on fire. The flammability would be more like staying on fire, okay? Being able to burn, how flammable it is. Rusting, okay, so forming of rust. When you have a metal, like this example, it's a chain. When it's exposed to water, so if you have a chain on a boat or something, especially, you see all this little rust that's on the chain. That's a new substance that's being formed. The metal is reacting with the oxygen in the air to form this rust, iron oxide, okay? And then if something reacts with acid, then that would also be, chemical properties are changing there, chemical reaction is happening, all right? So it's the characteristics that are shown when a chemical reaction takes place, chemical properties. What about physical properties? What about physical properties? Well, the difference there is that anything that physical properties are anything that can be observed without changing the substance. So without, here is your word that you want to put in your blank there. Anything that can be observed without changing the substance. Observations are usually a type of measurement, so that's usually quantitative, but there are also some that are qualitative. So let's think about physical properties here, okay? Melting point, boiling point. So the temperature, so remember, this is really, melting point and boiling point is really temperature, right? So it's a temperature at which a state changes. Melting point, boiling point, those are physical properties. Electrical conductivity, okay, that's a bit of a tough one. The ability for something to conduct electricity through it would be a physical property because we aren't changing the substance when electricity passes through it. For example, that copper wire that's maybe in the walls here that's taking the electricity from the switch to the light, that copper wire, when electricity passes through, that copper isn't changing into something else when that happens. It's still remaining copper, but it's allowing electrons to pass through the metal. Some other obvious ones would be hardness or odor, okay, so a smell, color, a descriptor, and density. We just talked about density, okay? So physical properties. And most of them are quantitative. So those quantitative observations, most of those would be physical properties. Now, odor and color would be ones that are technically physical properties, but they would be more qualitative, right? Okay. All right, so let's take a look at a summary here, properties of matter. Okay, so this little chart in your notes here will help you to determine physical properties, chemical properties, that sort of thing. So let's just work through this. So properties of matter. Okay, so the first question you want to ask yourself, are the properties that I'm considering, are they determined, so that can they be measured or described without changing the identity of the substance? Okay, so for example, pretend that I have an ice cube in my cup, an ice cube, okay? As that ice cube melts, okay, the water is in solid form going to liquid form, okay? So if I can describe what's happening there, because the water is not changing into something different, it's just changing state. So a lot of those descriptors that are changing would be physical properties, okay? So shape, hardness, right? Temperature, things like that, density even, okay? Physical properties. If I'm baking a cake and I see, you know, a new substance being formed inside the oven, right? That kind of thing, then those properties that I would be witnessing would be, you know, more chemical properties. So if they can be described without changing identity, you go over to this side, that's physical properties. If like reactivity or, you know, flammability, things like that, that's changing, the substance is actually changing, those are chemical properties. Okay? So what are some things that you could ask yourself here? How does the substance reaction to in the presence of, how does the substance reaction to the presence of? Okay, well, how does it react in the presence of air or acid or a base or water or other chemicals? So if something is changing substance, or if it is obviously being affected chemically, then those would be chemical properties that it would be exhibiting. Physical properties, okay? So you ask yourself another question. Does the property depend on the amount of substance? Okay? So we could further break down physical properties in, does it depend on the amount? If it doesn't, like the color, the hardness, okay, that kind of thing, the melting point, density, those would be intensive. Now, I think you want to highlight this term here. There's no blank, but just highlight this, intensive physical properties. This does not depend on the amount of substance present. So density, color, melting point, boiling point, those kind of things, even hardness, electroconductivity, those kind of things, it doesn't depend on the amount. Some physical properties that do depend on the amount are called extensive physical properties. And if you were to take some of that substance away, change the amount of substance or add to that, these would be physical properties that would be extensive, like mass, volume, length, shape, that kind of thing. Size, right? Okay? So that's further breaking down physical properties, intensive, extensive. All right, next in line here, physical and chemical changes. So we talked about properties. Physical, chemical changes, they're easy. What we do is we take a look at the situation and find out, and we have to ask ourselves, is this change purely physical, so only affecting physical properties, or is this change chemical? Is it affecting chemical properties? So here's some questions you can ask yourself. Is melted butter still butter? Yes or no? Yeah. If you took a hard block of butter and you put it in the microwave or something and you soften it up for 10 seconds, let's say, because you want to spread it on your pancakes or whatever, if you did that, you would put butter into the microwave and you would take butter out. So that change of temperature or that change of melting is a physical change because you haven't actually made a new substance. Okay? Is sour milk still milk? Oh, this is an interesting question. I see some people saying yes, some people saying no. So if you drink regular milk and then you drink milk that's 2 weeks old and that's been sitting out, is that the same? Would there be something new in there? The taste would be different, okay? There would be some chunks. So are we talking about just like separating milk or just like balling it up somehow? Like, are we physically changing that milk, or would there be some new substance in there that's affecting the taste and the smell and stuff? Sour milk. What do you think?
Well, anything that was not there wouldn't be there.
Okay.
It doesn't come out of nowhere. If you had closed the lid without getting any.
So the question was, let's summarize what we just talked about. The question was, if you were to seal a bottle of milk, a container of milk, and leave it out on the cupboard for 3 weeks or something, and then you crack that thing open, nothing has come in or out in that time. Nothing's been added, nothing's been combined with it, but you crack it open and we all know that it's going to smell bad, it's going to be rotten milk. So even though something hasn't come in or been added to it to make this sort of spectacular reaction, a chemical reaction is happening. There's something that's breaking down and some new substance would be forming there. So sour milk would be, you smell and you taste that something would be different in there, okay? So that would be a chemical change then, because we've got something that's very foul, something that's broken down, even though something hasn't been added to it. What about ashes? Are ashes from a fire still made of the same stuff as wood? Are ashes and wood the same? Have they been, is that a physical change or a chemical change? This is an important question. I guess some saying physical, some saying chemical. Yeah, what do you think?
So I think it'd be a physical change because of if you put a piece of wood in a fire
Yep.
for a long period, physical shape of it will
Okay.
either degrade or fall off, and if you leave ash will.
Okay, so if you put wood in fire, it changes shape and size and everything like that. So shape and size would maybe indicate physical change. Okay, so is the piece of wood that you put in the fire, if you were to collect it, even though it's kind of fallen apart and broken and maybe looks a little bit different, if you were to collect that all together and pull it out, would you have the same thing, or would there be something really different about that?
There'd be something different.
Okay, there would be something really different about that. And if you think about fire or burning, that's actually a chemical reaction. It's actually that substance is combining with the oxygen in the air, as I mentioned before. So burning, is it made of the same stuff? Well, the ash is actually a combination of the wood plus oxygen and different things. So it has actually something new. Now, some of these are not easy, but this is the type of thinking that I'm looking for here. So we will continue these notes next day. That's the bell. You guys may be dismissed.